Good morning, guys. Happy Friday. Welcome to today's lesson, April 10th. We're going to take another look at central and inscribed angles. Make sure you're working in Module 5, not Module 4. All right, good job on your Delta Math. Almost all of you completed it. If you are one of those people who did not, that window is still open until 8 o'clock tonight where you can receive 75% late credit. So make sure you take a look there. Keep in mind that there's still another 40% of your grade for the course with marking period 4. That grade is worth 20% of your grade for the entire course. And then there's another 20%, which would have been the readings exam, but that we're not sure what that is yet. It could be some sort of final exam, but there's another, that would be another 20%, so 40% in total. You have to make sure that you pass the class and do well in it to move on to Algebra 2 next year. Keep that in mind. Take these lessons seriously every single day and keep doing a good job with your Delta Math. All right, so today's due now. Which statement is sufficient evidence that triangle DEF is congruent to triangle ABC? So congruence, don't forget about your congruence criteria from Module 1, which where we have side, 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 angle, side, angle, side, angle, 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 side, and HL. So we have to meet one of those criteria. Choice 1, AB is congruent to DE, and BC is congruent to EF. Is that a congruence criteria? You should be thinking no. That would give us side, side. We would have needed that third side. So that's a no-go for choice 1. Choice 2, angle D is congruent to angle A. Angle B is congruent to angle E, and angle C is congruent to angle F. All right, is this one of those congruence criteria? The answer is no. This would give us similarity, actually. This would give us angle, or angle, angle, angle. All right, similarity does not necessarily give us congruence, so not choice 2. All right. Choice 3. There's a sequence of rigid motions. That's good. That maps AB onto DE, BC onto EF, and AC onto DF. Is this one of our congruence criteria? The answer is absolutely yes. This gives us side, 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 so choice 3 works. Now, if you tried this on your own, which you should have, you might have picked choice 4. Let's just take a look at that. It says there's a sequence of rigid motions that maps point A onto point D. That's really the issue here. A point onto a point doesn't give us a side length, a pair of sides congruent. It doesn't give us a pair of angles congruent. Right, it would have just given us AB and DE, and then angle B onto angle E. So that's a pair of angles, a pair of sides. That's not one of the congruence criteria. But once again, that whole point situation, that does not give us anything. All right, point onto a point, no good. All right, so we get choice 3. Now, guys, we're just looking at straight, central, and inscribed angle practice. I took all these problems today. I took them from Delta Math assignments. So coming next week, you'll see a bunch of problems like this. All right, they're pretty straightforward. We'll do about 5 or 6 of them together, and then you'll have 5 or 6 for you to complete on your own. So, in circle B, with the measure of angle ABC, so let's locate angle ABC, that's 42 degrees, which would be here. Find the measure of minor arc AC, so that essentially means the arc that that angle intercepts. So, what type of angle is this? You should be thinking it's a central angle. Remember, it opens up. That angle opens up and intercepts arc AC, which is the one we happen to be looking for. The central angle is equal to the intercepted arc, so it would be 42 degrees. Your final answer is 42 degrees. We're done. Very straightforward. Also, keep in mind, they could have asked you for this arc here. They could have asked you for the arc all the way around. Think about how you would also find that. We didn't need to for this problem, but that's definitely just something that could be coming in the future. All right. So in total, remember, guys, the circle is 360 degrees. So if we did 360 minus that 42, we would have found that they would call that the major arc, all right, because it's bigger, for 318 degrees. All right, remember 318 and 42, that makes 360 in total. All right, just a side note. All right, the next one. In circle G, with the measure of minor arc, FH. All right, so FH. Let's look at that arc there. That's our unknown. Excuse me, that's what they gave us. That's 106 degrees. Find the measure of angle FJH. So FJH would be this angle here. I marked with an X. So what type of angle is that? You should be thinking that's an inscribed angle from yesterday. Like the last one, it was a central angle. It meets at the center of the circle, where we have an equal relationship. Here, the inscribed angle meets at a point on the circle. Okay, it's made from two chords. All right, meets on the circle. Now, it's not an equal relationship. Remember yesterday, this angle, the inscribed angle, is equal to half of the intercepted arc. And just a side note, this angle clearly relates to this arc because the angle opens up like so, 1, 2, and hits that arc. But any which way, that angle would be equal to half of that 106 there, which would be 53 degrees. All right, final answer would be 53. All right, so the inscribed angle is equal to half of the intercepted arc. What is the intercepted arc? That's the arc that the angle opens up and hits. Okay, next. In circle K, with the measure of angle, and actually let me just stop for a second. At any point, you should be able to do all these questions. This is really just a review day. Right? Everything is so new, central angles, inscribed angles. At any point, you can just do this whole worksheet on your own if you want, and then come check with the video and the answer key later on. But I'm going to at least go through a few more with you, so you can follow along like this if you'd like, or you can just straight up do it on your own. Your choice. All right, so in circle K, with the measure of angle JML equal to 30 degrees, find the angle measure of minor arc JL. So JL is here. So the angle that they gave us and the arc that they're talking about, they're related to each other in the respect of one, there's an angle, and then there's an intercepted arc. All right, and it's that angle's intercepted arc. So this angle opens up and hits that arc. Now you may fall into this trap and say, okay, 30 degrees, all right, we have a half situation here, okay, 15. Not quite. All right, now they gave us the angle and they're asking for the arc. The arc is double the angle. All right, just like before, the angle here is half of the arc. The arc is equal to double the angle. So this would be 60 degrees here, guys, for JL. All right. Now, just be careful that this is not, I just want to point out, if they asked us to find something else, something else in here, JM is not a diameter because it didn't perfectly pass through point K. So you can't say that this arc over there, you can't say that that's 180 degrees. It would actually end up being a little bit more. All right, but it's the reason it's not a diameter, so to make a perfect 180 degrees, it did not pass through that center point K. It's actually, JM is a chord. It's not a diameter. I know yesterday we talked a lot about diameters and 180 degrees. So now it gets a little trickier. In circle K, with the measure of angle JKL, so JKL, 114, find the measure of angle JML, which is here. Now what I want you to see about the two angles they're talking about, they intercept the exact same arc. So JKL, right, opens up, and the intercepted arc would be JL. Same exact thing for JML. As that opens up and hits an arc, here, right, they intercept the exact same arc. All right. So if we have that arc, we can find both of these angles. Now, so JL is what we can find. That's the arc that gets intercepted. That's equal to the central angle, so that would be 114 degrees. And then X, what we're looking for, angle JML, that would be equal to half of that arc. All right, so take 114 and divide that by 2, and you get your answer. So you get 57 degrees. Final answer. All right, let's keep moving. In circle C, with the measure of angle BED equal to 30 degrees, find the measure of angle BCD. So BED is 30 degrees. We want to find the measure of angle BCD, which is right here, exactly where that letter C is, right there. All right. Once again, let's check to make sure that the two angles that they're talking about, that they intercept the same arc. So the 30-degree angle opens up and hits an arc. So the arc it intercepts is BD here. Right? Now the angle, the central angle in there, does it intercept the exact same arc? Let's check. It opens up, hits, opens up, hits the exact same arc. So both of these angles hit the same arc. So what we can do, we can find that arc using the inscribed angle of 30. So 30 times 2 will give us 60, and that'll give us that arc there. And now the central angle we're looking for, angle BCD, is also equal to 60. The central angle equals that arc. All right, so angle BCD, 60 degrees. All right. In circle C, with the measure of angle BED equal to 66. All right, let's fill that in. Always they tell you something, fill it in. Angle BED is 66 degrees. Find the measure of angle BCD. All right, so BCD is here, central angle. Now once again, I really want you to see that both of these angles intercept the same arc. Think about what arc right now that they intercept if you have to pause the video. But what arc is being intercepted? What arc is being hit by the angles when they open up? So this one opens up and hits arc BD, and this one also opens up also hits arc BD. Very important to see. So to find that arc BD, the one that's being hit by both, we would have to double the inscribed angle. The inscribed angle is 66, right? So if you double that, you can get the arc. Remember the relationship. Are you given the angle and need the arc, or are you given the arc and need the angle? When you have the inscribed angle, you double it to find the arc, which would give us 132 for that arc. Now to find the central angle, just like the last one, that's the exact same degree measurement, which would be 132. All right. Now this one's a really great one to talk about further because we can find so much more than that. You can find the angle that's next to our initial x value because there's a linear pair there. All right, linear pair with 132, think about what that would be. This would be 48 degrees. They didn't ask us for any of this, but it's just good to talk about. That would be 48 degrees. That's a central angle. That would give us 48 degrees here. And that makes sense because this is a diameter, guys. This line EB or BE, that's a diameter. So 48, right, if we're starting here, 48 and 132 all together should give us 180 degrees, and it does because that's half of the circle. And over here, on the other half of the circle, that arc, that whole arc I just marked in yellow, that has to be 180 degrees. All right, because that has to be a diameter, EB. They didn't tell you it's a diameter, but you should know that because it goes from one side of the circle to the other. All right, it hits the circle twice and passes through the center of the circle. Anytime they say circle C, that means C is the center. All right, so just a good one to expand on. All right, and this is the last one we'll do together. The rest of them, you check the answer key. And also message me and remind for sure. All right, encircle Q, that means Q is the center, with the measure of angle PSR equal to 18 degrees. So that's a tiny angle, PSR, 18 degrees. Find the measure of angle PQR, which is right there. Now these, once again, what I really want you to see today, hopefully you're picking up on, the two angles that they're talking about, they intercept the same arc. They hit the same arc. So 18, look how that opens up. That hits arc PR. And the X value that we're looking for angle PQR opens up, hits that exact same arc. So the focus, guys, the arc we're really focused on right now is PR. All right, so how would we find PR? Let's think. Remember, that arc is equal to double. All right, that's equal to double the inscribed angle. The inscribed angle is 18 right now. Double that, you get 36. The central angle is equal to that exactly. So this would also be 36 degrees. All right. So guys, you basically are just going to run through this same exact setup of questions. Again, just a central angle, inscribed. Gets a little trickier where they give you two angles that intercept the exact same arc. All right. Please make sure you're asking questions and remind. The Delta Math window is still open. All right. It's really important with this lesson and all the lessons that you go back, all right, and check your work. So you're going to do these problems independently. Don't just assume you got them right or wrong or whatever. Do them, and then I'll post the answer key around 5 o'clock today, and you can check your work, see how you did. I should be seeing, check marks. Okay, yeah, I got that one right. All right, this one I didn't get right. What did I do wrong? Correct my work, and you'll be in great shape for Module 5 because this is really the foundation. All right, guys, have a wonderful weekend, and I'll see you on Monday.